Hello, let's do the New York Times Hard Sudoku for December 1st, 2024. There's a link in the description if you'd like to try it yourself, and I'm going to get started right now. All right, we're going to start with this 4 and 7. So the 4 has a buddy here, and this 4 looks up, placing the 4 in this box. There's only one place for 4 in the box, so that's where it has to go. These two 4s look down, just following up on the digit I placed, in case it does something interesting. Okay, so the 7 doesn't have a buddy in the band, but it does have these two 7s in the stacks for those bands. So we can look at the effect of that. So this 7 and this 7 leaves a 7 in one of these two cells. And this 7 and this 7 puts a 7 in one of these 3, which we can't do anything about right now. We also have 1, 5, and 8. We took care of 4 already. So the 1, this one looks in, this one looks up. It's not quite enough. The 5 has a buddy here. This 5 helps, puts a 5 in one of these two. And then the 8, we have the 8 looking in here, this 8 looks up, and this 8 looks up. So in this box here, the 8 gets placed. It's the only place for 8 because of these 8s. Now these two 8s look into here. This 8 looks up, putting an 8 in one of these two cells. Now what we've done here is we've corner marked the 5s and the 8s in the same two cells and no others. What that tells us is one of these cells must be 5, and then the other one must be 8. Because we need a 5 and an 8 in the box. And these are the only two cells that can do that. So this is what's called a hidden pair. So we can actually just say these are only 5 or 8. And what a hidden pair does is it removes anything else that we thought could be in those cells. So for example, 1 was removed from both of these. This one looks up, this one looks in. The hidden 5-8 pair says you can't put 1 there. We won't be able to fit the 5 and the 8. So the 1 ends up here. Let's follow up on the 1. Just put a 1 in one of these two. 2 was also removed. This 2 looks in, but it's not good enough. 3 was removed. Well, no, 3 wasn't, because 3 was already here, but I hadn't scanned it yet, but you can see that 3 is actually placed. And then these two 3s look in, placing this 3. 4, 5, so the 6 was removed. Well, we know this is a triple, so just what is it? It's 2, 4, no, not 4. 2, 6, 9. That's not a 2. Okay. And that makes this a pair. So we have 1, 2, 3. We need a 4. 4 and 7. It's not resolved. Okay, nice. This 5-8 pair also is a 5-8 pair for the row, but we already have this 5-8 and this 5-8, so it's not helpful. Okay, so I was looking at 1, 5, and 8. I took care of those. Now we can look at the 2 here. We have two 2s looking up here, so that places this 2. And then the 2 in here gets placed. Nice. This is just 6 or 9 for the row, but this 6 looks up, saying it's not 6. That's 9, that's 6, that's 9. There's only 3 digits left, three digits left here, so it's easier just to think about what those are. We need the 1, 6, 7 here. We see the 6, 7 below, but that's it. Oh, the 1 looking in. I missed that. So we place the 1, the 7, and the 6 then. Well, this whole top band is just getting finished. 1, 2, 3, 4, we need 6, 7, 9. So the 9 looking in tells us that's a 9. And then this 7 looking up tells us that's 7, that's 6. Wow, this whole top band just finished. Except for this little 5-8 pair here. Because this band is basically done, I think scanning the stacks is going to be more fruitful because we have these completed boxes here. So I'm just going to scan the stacks here. So we have the 5 and the 6. The 6 looking up here, this 6 looks in, puts a 6 in one of these two cells. The 5 isn't really going to do anything here. We also have the 1, 3, and 8. So the two 1s we got, the 3s, put a 3 somewhere down here. And then the 8 we don't know much about. Okay. 1, 3, and 8 we also want to look over here. So the 8 and the 8 look in, but that leaves 8 for one of these 3s. So that's not helpful. All right. We have the 6 and the 7 here. So these two 6s look down, putting a 6 in one of these two. Ah. Sorry, this 6 helps. I missed that. All these 6s look in. Placing this 6. We have two 6s here now, and this 6 looks down, placing this 6. Can we do more with 6s? I bet we can. Yeah. So I think these are our last 6s. We have 6s in every box except these two boxes where we're down to a rectangle. The 7, these two 7s look down, puts a 7 in one of these two. We also have the 8. These two 8s look in, putting an 8 in one of these two. And then the 9s join the 8s. So this is a hidden 8-9 pair. That leaves a triple down here. We need the 1, We have 2, 3, we need 4 and 5, and then we have 6, 7, 8, 9. So that one's not 5. So we got the 9, the 8, 6, 7. Anything else to do here? This is going to be a triple, because this is a triple already. So we need a 2... what did I miss? 2, 3, and 7. This one's not 7, this one's not 2. So the 2 ends up in one of these two cells. That points left along with this 2, putting a 2 in one of these two cells. Okay. This column has been reduced to 4 digits, and we know only the 2, 3 goes down here. So there's going to be 2 digits limited to these 3 cells at most. But what are the digits? We need 1, 2, 3, and 5. So this 1, 2, and 3 allow us to pencil it. 1, 2, 3, 5. That's not 1, 3, or 5. Oops. 1, 3, or 2. So we know that other than 2, 3, we have 1 and 5. So the 1's limited here and the 5's limited here. Okay. And yeah, that's true. So anything we haven't accounted for in here might be interesting. So 1, 2, 3, the 4 might be interesting. Yeah, so 4 is in one of these two cells. 5, 6, 7, 8, 9. Okay. And then down here we have everything penciled. Okay. But these aren't 1, 5, 8, 9, 6, 7. 1, 5, 8, 9, 6, 7. Yeah, we should just pencil these. So they can't be 1. This top one can be 2, but not the bottom one. They both could be 3. They both could be 4. That should be it. 5, 6, 7, 8, 9. Yeah, that is it. So 3, 4, and 2, 3, 4 is what's left for those. Okay. I'm going to look at this final stack here. So we've got the 2 and the 4. So the 2s are done. The 4s we have marked. We also have the 6 and 7. So the 6s look in. We have that marked. The 7s look in. Not marked. And actually we can place it. So we place that 7. These two 7s look in here. This 7 looks down. Placing that 7. This 7 looks... Oh, we have the 4, 7 pair here. Okay. These 3 cells are not 1, 3, 7, 8, or 6. 1, 2, 3, 4, 5. Let's see what they can be. So they could be 2. These 2 could be 2. Can't be 3. 4 is one of these 2. 5 is any of them. 6 is over here. 7, 8, and then 9 is any of them. So we don't want to mark this one, but we have 2, 5, 9, and 4, 5, 9. It's amazing how this puzzle is not collapsing after this top band finished. The 3 digits left in this column. We have 1, 2, 3, 4. We need 5, 8, 9 here. 8 can only go here. We have this 8 and this 8 telling us not there. So we're down to 5, 9 here. And the 5 tells us this is 9 and this is 5. That means this is not 5 and this is not 5, but that does not place a 5 anywhere. Okay, let's see. We got this 5 and 7. So the 5s all look into this box, placing this 5. And then in this box, 5 is placed. All right, 3 digits left in this box. We need the 1, 3, 4. We just know this one's not 4. So 1, 3, 4, that one's not 4. This whole column is 1, 3, 4, 9. So we know the 9's up here. So those 9's line up. We have the 8, 9 pair here, and the 9's are limited to these 2. And so where's the 9 in this row is always the question. Not in this box, not in this box. So the 9's in one of these 2 cells. That means this cannot be a 9, because if the 9's down here, that's called claiming. Row 6 needs the 9 to be in one of these 2. Whichever one it's in will be in box 4, meaning the rest of box 4 can't have a 9. So that's not 9, and these aren't 9 either. So now this should be markable. In fact, let's think about both of these, since they aren't 9 anymore. They're not 1. They could be 2, can't be 3. This could be 4. They can't be 5. So they can be 5, sorry. This left one can be 6. Can't be 7, 8, or 9. All right. 2, 5, 6, huh? This can't be 1 or 3, and we know we need 1 and 3 in the row. So this is going to be limited. It's not 1, 2, 3. Could be 4. No, it can't be 4. Can't be 5. Could be 6. Can't be 7, 8. Could be 9. So it's down to 6, 9. Nice. I feel like I haven't penciled the right things here. So these are 1, 3, 4, 9. Okay, I can mark these because they can't be 4s. And this sees 1 and 3. So 1, 3, 4, 9. They both can't be 4s. This can't be 1. This can't be 3. 3, 9, and 1, 9. Surely something's going to match up at some point. This column is down to 1, 3, 6, 8. They all see something. 1, 3, 6, 8. Oops, 6, 8. That's not 1. That's not 3 or 6. And that's not 8. So this is a 1, 8, 9 triple. Naked triple. This is the kind of triple that always people have struggled to understand why it's a triple. They could understand why this is a triple, but not why this is a triple. And so let me explain. It works, the logic is exactly the same. Unfortunately, I think a lot of people memorize triples as a pattern rather than understanding the logic. So I need 3 different digits for these 3 cells because they all share a row. Because they're all in the same row, I need 3 different digits. That's the important bit. If they can be the same digit as each other, then you can't do this logic. But because they all have to be different digits from each other, they cannot be the same digits, what 3 digits will they be? Well, the only digits I have available in total are 1, 8, and 9. I know this can't be 8, this can't be 9, this can't be 1, but in general, there isn't another digit available. I can't put a 2 in any of them, can't put a 3 in any of them, etc. I can only put 1s, 8s, and 9s. And since I need 3 different digits, and 1, 8, 9 is 3 digits, they are going to use up the 1, 8, and 9. They can't use any other digits, and 1, 8, 9 is exactly the number it needs. So if these are going to use the 1, 8, and 9, how could this also be a 1, right? If you tried to make it a 1, look what happens. If I try to make this a 1, this becomes 8, this becomes 9, and this has nothing it can be. Or you'd end up with like 2 1s in the row somehow. So this can't be a 1. So if that can't be a 1, so we remove 1, 8, and 9 from the rest of the row. Because it was the row they couldn't repeat in, it's the row that they removed from. So if that can't be a 1, that places the 1 in this box. There we go. Don't need that highlighted. 3, 6, 3, 4, 4, 9, 6, 9. So this is just, this can't resolve itself. I have almost everything penciled. These are 1, 2, 3, 4. This can't be a 1, so it's 2, 3, 4, 2, 3 only, actually. It can't be 1 or 4. This can't be a 3, so this is 1, 2, 4. Did I get any? So I got the 3, 6 here. I got the 3, 6, 8 here. I'm trying to see if I formed any other interesting pairs or triples. It does not appear so. Very interesting. No, I was going to say these 4. Oh, I have this 4, 7 pair, right? So I should not have penciled 4 here. But importantly, these 4s line up. When I penciled these 4s, I saw these and I said, no line up. For some reason, I didn't check over here. But yeah, these 4s line up. So we can't have 4s in any of these cells. And so in the row, where's the 4? And the answer is just right here. So we could have seen that. As soon as I cleared this 4, it was obvious. But that's a 4, that's a 1. What did that do for me? 4 and 1. It did not do enough. 2, 4, 5. 1, 2. Okay, I need to find more. 1, 2, and 3. I need a 4 in this column. I guess it's just one of these two. That doesn't actually help me. So what is this digit then? It could be 1. It can't be 2, 3. It can't be 4 because of the 4, 7 pair. It can't be 5, 6, 7 because of the 4, 7 pair. Could be 8, but can't be 9. So we're down to 1, 8 only. In fact, where is 8 in this row? And the answer is only one of these two cells. Doesn't really help me. I feel like there's something I didn't scan. Amazing that we finished the whole top band and this is still hanging on like that. These two 9s, there we go. That's what I didn't scan, is the 9s in this box. So the 9 gets placed here. That gives us the 6 and the 9 and the 4, leaving a 2, 5 pair behind. That places this 4 and 3. We get our 1 down here. That gives us the 1 and the 8 and the 3 and the 2. That gives us the 5 and the 2. That's our 5 and 8. That's our 3, 2, and 5. We get our 8, 6, 9, 1. We get our 9, 8. 7, 2, 3, 4, and 7, 4, and 3, and we're done. All right. Yeah, I think I got lost in the weeds a bit there at the end, but Yeah, interesting puzzle for sure that this top band just completed, and it was still hung on for a bit. But it was these 9s that I didn't scan. When I placed this 9, it must have been that I didn't properly follow up on it because we had those, I guess. All right, cool. Well, how did you do? Hope you enjoyed it. If you did, then why don't leave a like, subscribe, and a kind comment below.